Hello and welcome. Sorry, I was muted. Hi, everyone. My name is Jasmine Shoemaker, and I, along with my colleagues Joe Lee and Lorraine Ojo Ohaikwari, founded the UMBC Library Symposium series, AI, Privacy and Ethics, Oh My, unpacking the questions surrounding artificial intelligence and higher education. The symposium's inspiration comes from the ever-changing landscape of AI and the need to know information for higher education students. The series supports the university's vision of supporting excellence in higher education by connecting innovative teaching, learning, and research to our community. We are intentional with the selection of our speakers, remaining mindful to include librarians, teaching faculty, and students from diverse backgrounds. Our series would not be possible without the contributions from the following centers, departments, and organizations: the Library Freedom Project, UMBC's Center for Social Science Scholarship, the Department of Information Systems, and the Department of Computer Science and Electrical Engineering. Today, we welcome Tim Finin, our first speaker of the series. Dr. Finin is a professor of computer science and electrical engineering at UMBC. He has over 50 years of experience applying AI to problems in information systems and language understanding. His current research focuses on representing and reasoning with knowledge graphs, analyzing and extracting information from text, and enhancing security and privacy in information systems. He received an SB degree in electrical engineering from MIT and a PhD in computer science from the University of Illinois. He has held positions at UMBC, Unisys, the University of Pennsylvania, Johns Hopkins University, and the MIT AI Laboratory. He is an ACM and AAAI Fellow, received an IEEE Technical Achievement Award, and was selected as the UMBC Presidential Research Professor in 2012. Dr. Finin's presentation today is titled, After 75 Years of AI, Can Machines Think? We welcome questions in the chat throughout the session. Questions will be asked at the end. And with that, I will turn it over to our speaker.
Well, thank you very much. I enjoy the opportunity to talk about this, and I hope there's nothing special about being the 1st of April. Let me share my screen if I can. Let me share. Am I sharing just my window or the whole screen?
We see the window with your desktop in the background.
All right. Let me try this again. Now, do you just see the presentation window?
Correct.
Okay, good. Well, thanks again for inviting me. I enjoyed putting together some notes on this, and I hope that makes sense. So what I'll do today, I hope, is start by covering some AI history, because it's important about what led up to recent advances in AI. But I'll talk a lot about the generative AI systems, which have created a kind of inflection point in AI, what they can and can't do well yet, and a little bit about the risks and potential misuse of the AI technology, a little bit on what might come next, and end up again with the question, can machines think? So here's my bottom line up front, BLUF, which is a perspective based on a little more than 50 years of working in AI. And that is that we've not solved all of AI's problems, nor yet developed what's called an artificial general intelligence. More on what that means later. But ChatGPT and other similar systems like Copilot, Google's Gemini, Claude, do show remarkable and useful capabilities that, one, are being integrated into software systems like web browsers, editors, programming environments, spreadsheets, and more. And two, can and will be improved by adding current and future AI advances. So my view is that the impact of this on society will be like that of the impact of the World Wide Web, which was introduced about 30 years ago. And there's a great law, which I just learned about last year, called Amara's Law by Roy Amara, who headed the California uh, Institute of the Future for many years. He said, we tend to overestimate the effect of technology in the short run and underestimate the effect in the long run. And I think that's very accurate and applies, for example, to the web and many other things as well. So I'll start with a little history. Charles Babbage invented the first concept of a mechanical computer, and for him it was really mechanical in 1832. He designed it and partially built it, but saw it just as a number cruncher, something to do mathematical computations more easily. His colleague, Ada Lovelace, who is considered to be the first programmer, saw that numbers can represent other entities, and this would enable machines to reason about and compute about anything. But she had a more limited view. One thing she wrote was the analytical engine, which is what Babbage called this computer, has no pretensions whatsoever to originate anything. It can do whatever we know how to order it to perform. So going forward a little bit on the history of AI to 1950, the Turing test. Alan Turing was an important mathematician and early computer scientist who devised a simple test to evaluate if a computer can think, and he wrote about it in his 1950 paper. The idea was that there are three rooms. There's an interrogator who is connected electronically and can converse with people in two rooms. One of them, and he doesn't know which, is a computer, and the other is a person. And the interrogator's task is to have a natural language conversation with both of the two rooms and try to predict from that conversation which one is the machine and which one is the person. If the interrogator can't do it reliably, correctly, then Turing said we could conclude that the computer could think. It's a pretty interesting test. It has been tried many times in the past. So far, computers have not fully passed it, but I don't know if it's been tried with the most recent generative AI systems. Jumping forward a little more, where did the term artificial intelligence come from? Well, it came from John McCarthy, who was one of the AI pioneers, who for most of his career was a professor at Stanford, but also had been at Dartmouth and MIT. In 1956, well, in 1955, actually, he proposed that the government fund a workshop in Dartmouth in the summer of 56, a 2-month, 10-man study. And he used the term artificial intelligence to say what they wanted to study. And if you read the proposal, which is online, if you follow this link, you see that he thought they were going to make great strides in this 2-month study. But here's a picture of some of the people who were at that thing 50 years later, and many of the attendees at that workshop are thought to be pioneers of AI. So here's what John McCarthy, how he defined it. This is just maybe about 10 years ago at his website. He's since passed away, unfortunately, about a definition of what artificial intelligence is. He wrote, it's the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. And as kind of the view of most AI researchers and applicants over the years. Um, so he also had a page in his website on what is AI or what is intelligence. And he said that intelligence is the computational part of the ability to achieve goals in the world. Varying kinds and degrees of intelligence occur in people, many animals, and some machines. So he tied it to achieving goals in a complex environment, which is our world, not just through speaking a natural language, for example. Well, let's go ahead a few more years to 1966, when Joe Weizenbaum, who at the time was a professor at MIT, developed a simple program called ELIZA and published a paper on it in the ACM journal. It was a simple and very early chatbot, but many people believed it understood human language and kind of represented an intelligent agent. And its default model that had many different scripts was sometimes called Doctor, but its default model simulated a psychotherapist. So Weizenbaum's goal in doing this research was to show how easy it is for a program to appear intelligent. And in fact, there's a term called the ELIZA effect that has been used to uh, describe what happens when people ascribe to a dumb system that intelligence just because it seems to use text well. And if you look at the ELIZA conversations, after a while, you might see that it's really fueled by some simple pattern matching and sort of general responses. In fact, if you use Emacs, the Emacs editor, there's a Doctor script that's built into Emacs that you can run to play around with one version of ELIZA. So over the years, since say 1950, the AI field has had many ups and downs, but like the stock market, the overall trend is up. In the 50s and 60s, it was up, but then there was an AI winter in the 70s when people thought, oh, AI has been oversold and it's not going to solve all the world's problems in the next few years. Uh, and then in the 80s, it was up again with the invention of expert systems and rule-based reasoning. And that maybe got oversold a little bit or overhyped, and it was down again in the 90s. I will say that I enjoyed the time when AI was in winter more than the time when it was in summer, because you could sort of kind of work at a more appropriate pace for doing research and there wasn't too much hype. In the 2000s, it was up and then down a little bit. And in the 2010s and 2020s, it's up. And right now, it's way up. So the hype will probably reach a peak point and then descend a little bit. The most recent sort of advances have been due to machine learning. And these have been supported by and require increased computing power with parallel computing and also access to large amounts of training data, which often means pulling in everything you can from the web. So yes, I think we're clearly in another AI inflection point where some new ideas have been demonstrated that we're still figuring out how to take it maximal advantage of and advance to the next step. And what what kicked off the current inflection point, a big upcycle on an even more regular up trend, was when the company OpenAI released ChatGPT at the end of November in 2022. And this showed the potential of what is generally being called generative AI systems, which I'll abbreviate as GAI systems in this presentation. Their chat GPT conversed with people to answer questions that you would type in normal text, and it could generate a textual answer. It could also generate images using another one of their products called DALL-E. I'm sure many of you are familiar with both these systems, both the earlier versions and the current versions. Lots of other companies, including Google, Meta, that's Facebook, Apple, Microsoft, have since released similar systems, and there are open source ones that are also available. In fact, Microsoft has now kind of invested a lot of money in OpenAI and is using it extensively. So this has caused many people to see the benefits, to triggering interest, the excitement, and a lot of hype. But it's also caused many people to see their potential shortcoming and risks and raise concerns about them for the future. So one of the things that's fueled these new systems is neural network technology. I remember being a student in the 70s and hearing from Marvin Minsky, one of the founders of AI, that neural networks will never work. In fact, he and his a colleague wrote a book about showing why they would never work. But over the years, more ideas about neural networks and better computing power have made them the current hot technology. The GAI systems use huge neural networks that are trained have billions of nodes and trillions of parameters. And these are trained with data to perform tasks like text and image understanding and the GAI systems. Advances in the 1990s and 2000s, like the backpropagation algorithm, enabled them to be effective. But they do require high performance parallel computing systems to train them and to execute them. And these things just weren't around in the 70s and 80s and 90s. Here's a little GIF that shows kind of a neural network being fed an example to be trained and using backpropagation to adjust the parameters that the weights that connect all the neurons in the system. So today, these GAI systems use what are called large language models, abbreviated LLM. These language models have been used for decades to support many applications like autocomplete, speech recognition, and language translation. These things we've taken to be just common technology today. In fact, they're being used right now, I think, to capture what I'm saying as text. But large language models like OpenAI's GPT-4 use neural networks trained on huge text corpora from the web and books. And basically what these large language models do is, given some text, they predict what should come next. And so it's a probabilistic model. A trivial example would be if the words are the, followed by fluffy, followed by cat, then a large language model might say, well, one of the words that could follow next would be meowed. And it might say another one could be ate, and another one could be chased. And each one is associated with some kind of probability to say how likely it is. So some have called these large language models stochastic parrots, disparagingly, in that they can generate coherent text that seems to make sense, but they don't necessarily understand what it really means. But that's the sort of the basis of the technology. And in particular, in 2017, there was a paper that came out of the Google researchers about a new way to construct these large language models called transformers. And the idea is transformers see how to transform initial text into more text. And they used some new ideas. They used word embeddings, which I won't really define, but it's a way to automatically from a large text learn how similar certain words are in a given context. And what's called an intention mechanism, which is a way for the system to, if it's looking at a large text, sort of understand what words in it are really important and pay attention to them in making its decision about what should come next. So these transformers are expensive to create in cost and energy. GPT-4, for example, has almost 2 trillion parameters, over 120 different layers in the neural network, and it's been estimated to have cost more than $100 million to construct and train. Well, smaller pre-trained large language models can be pretty effective, and many are available now as open source. For example, Meta has made some of its models that it's trained with a lot of text available for people to experiment with. And there's a site called Hugging Face that has a lot of open source models that you can download and experiment with and use to try out some of this technology. All right, so if you have a large language model, what good is it for predicting text? Well, you know, answering a question is kind of like predicting text. You know, if I say, who's the president of UMBC, the prediction you might want to have is, they're going to say, a particular person. So LLMs are called foundation models since they're the basis for building or supporting multiple AI applications. And these applications might be things like language translation, sentiment detection, or question answering and coding assistance. What's code got to do with it? Well, um, computer programs are built with text, and these large language models have analyzed a lot of computer programs that are available online for free from educational sites or for GitHub, and learned a lot from how to generate text and how to explain text. But LLMs then have a fine tuning process where you take the foundation model and you further train it by adding additional components to the neural network to support a particular task, like question answering, sentiment analysis, information extraction, information captioning, object recognition, instruction following, or whatever. So this uses what's called supervised learning, where we have like, here's a question, here's a good answer, here's a question, here's a good answer, and also reinforcement learning, where once the application's been built, we try it out on a lot of data, and we give some feedback to the system like, oh, I didn't like that answer. That was a horrible answer. That's a great answer. That's an okay answer. And again, additional training is done to adjust the neuron weights. Now, the problems with current generative AI systems are many, and you're probably familiar with a lot of them. One of them is if you ask ChatGPT something, it's going to give you maybe an answer, but it doesn't always, it very only occasionally cites a source for where that answer came from for your confirmation. And that's bad because it can sometimes, what's called, hallucinate some facts. Now, here's a question that was asked early on for GPT-3. When did Leonardo da Vinci paint the Mona Lisa? And whoever asked it and, posted about it said, I got the answer. Leonardo da Vinci painted the Mona Lisa in 1815. And that's just not right. And there was no prominence given to find out where it came from. Another problem is that they lack common sense reasoning. I recall early on asking how many US states have a town named Washington, and I got the answer 25, which I think was pretty accurate. And then I asked a follow-up question like, how many towns named Washington are in the United States? And it said there are only 9 US towns named Washington in the United States. Like, these two answers don't seem to make sense to a common sense reasoner like a human being. Well, there are 25 states who have it. Well, maybe some cities are shared by 2 states, but wouldn't be a lot of them, would they? So this was another example where common sense reasoning would have told the system, oh, this doesn't seem right. I better look into this a little more. They have poor mathematical and logical reasoning. Well, the math reasoning has been updated recently, and they can do some math, but they still can't do logical reasoning as well as people. These are skills I think people have to learn in addition to learning how to work with language. They can learn social bias from their training data and misinformation from their training data, because a lot of the information out there on the web is biased in one way or the other, and a lot of it's wrong. The builders of these systems have tried to weed out this data and prevent the systems from being using it, but it's still a problem. And finally, there's a potential that these systems could be poisoned by intentionally ingesting intentional disinformation into them in some way. This is a partial list of problems and errors that are being addressed. today. Some are partly solved, but some of them will take much more work. So if we think about reasoning by people and machines, it's somewhat different. AI up until the 90s was mostly done with programs based on logic and formal algorithms. Uh, People can reason, but not always well. For example, people don't handle negation and disjunction particularly well. And our reasoning is neither sound nor complete, to use the mathematical terms. But people do reason more formally using math, logic, and probability and other systems. Now, one book which I highly recommend, great book by the Nobel Prize winner Daniel Kahneman, who unfortunately passed away last week, is called Thinking Fast and Slow. And he articulates a model for thinking for people and machines too, that he helped develop. He saw our human systems, and maybe only human systems, as having a system one that operates automatically, quickly, with little or no effort and no sense of voluntary control. And it's probably shared with the animals. And a system two, which allocates attention to effortful mental activities that can include complex computations like logic, arithmetic, writing software. So here's an image from his book. Um, and system one, he says, it involves intuition and instinct. System two involves rational thinking. System one is what we do most of the time. It's unconscious, fast, and associative. Rational thinking is what we do maybe 5% of the time. It takes effort, is slow and logical, and people don't do it so much because they're lazy. And an example might be to a police officer in a store might think, hey, that person looks suspicious. And that could be system one that's detecting some behavior that triggers this the sense that that person is suspicious, or might think more rationally, like Sherlock Holmes. Who would have the motive and the means and the opportunity to, steal stuff from this store? So here's an example question that sort of highlights system one thinking. And if you think quickly, many people, if you haven't seen it before, will give the wrong answer. A bat and ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? Well, the correct answer is 5 cents. If you do the math, that's what you get. But many people instinctively and quickly say 10 cents. And that's because our system one kind of works almost automatically to come up with that. And there have been a lot of books written about this kind of stuff, and besides thinking fast and slow. We get a correct answer if we use our system two to do the math reasoning. But this is something we had to learn through, a lot of work in elementary school. It's not something that occurred naturally. So beyond today's generative chat systems, we could see this as the evolution of computer-assisted technology. The earliest information retrieval systems were mechanical, and there was a great advance to having them done by computers and much faster. And then there was web search, which made it even better, easier for people. We didn't have to learn the special computer IR system that your school maybe had. And then the web search engines would be able to search and maybe come up with answers like they do today. And then many of us are familiar with writing help through systems like Grammarly, and programming help through systems like GitHub using Copilot. So this is because these large language model size have been applied in many of these things. Their size has increased by a factor of 10 every year since 2018, and their competency and performance is somehow related to their size and the amount of work they've been trained on. AI researchers are working to identify and address shortcomings, like the ones I mentioned, by adding links to provenance if they can, doing common sense reasoning in some cases, using access to structured knowledge for problem solving, using more logic and math, and more. So here's a couple of examples just to highlight this. Um, Previously, maybe a year ago, the large language models couldn't do arithmetic. I tried this yesterday. I put into ChatGPT, what's the value of, and I typed this in, and it quickly came up with this answer. And it included this little thing over here, which, if you click on it, has some provenance information. And what it does is it shows a little program that I think it generated to generate the answer. So this is an example of a GAI system recognizing that, oh, this is a mathematical computation, and I have a special module I can call that'll generate a program, and I can run the program and get the answer. I'll try that. That's pretty good. Sort of a generalization on this idea is called retrieval augmented generation, which AI systems are beginning to experiment with now. And RAG works for some queries by first retrieving information from an external knowledge source. One of the problems with the GAI systems is they've been trained on a lot of historical data, and it's not always up to date. So the idea with RAG is if somebody asks a question like, what's the population of Belgium? What it'll do is it will say, oh man, this is a time varying thing and my data is not up to date. So what I'm going to do is I'm going to, I've got a module that can send a query to Wikipedia asking this, getting the page it says, and putting that into my large language model to analyze that and see if I can come up with an answer. And it does. And the answer it gives is, as of my latest statistics in 2021, the population of Belgium is approximately 11.6 million. And in fact, when it does this, I think, as I recall, it has a link to the source that it got this information, the text from that it used to extract the information. So if we're using GAI systems, we can also improve them by what's called prompt engineering. And the idea is that you learn to give a longer, more complicated prompt. That's your question you want, or your instructions to the AI system to get it to generate an answer. And there's even a thing called chain of thought prompting, where you break down a problem into lots of steps and you put in each step into the system one by one. And these systems understand that they're building the second question on top of the results of the first question. And that seems to help sometimes. So here's an example. Uh, Another example of extracting data from a figure. So I'm involved in was involved in some research and still am in extracting and using data from figures from scientific papers. And we did a lot of work with papers from PubMed on healthcare issues. So in ChatGPT, if you want to ask a question about a figure, you can click on this paper clip and it'll say, okay, upload the figure. And I uploaded a figure from one of my files of a data chart. And then I clicked on this arrow to say, all right, now please answer this question. Please describe the data charts in this figure. How many are there? What are they about? Put your answers into a JSON representation. JSON is a common representation used in a lot of programming language for semi-structured data. And really quickly, here's the uploaded image. And like in a lot of papers, there were multiple charts in one figure, one image. I uploaded that as a JPEG. And here it did a very good job of explaining what this figure was about and extracting the data that could be useful for a system that tries to automated system that tries to use the data. I thought that's pretty remarkable. Oh, here's something I tried just today. I saw on the web this cartoon. Uh, yeah, person one is telling person two, hey, I turned this single bullet point into a long email I can pretend I wrote. And in the second one, the recipient says, hey, AI made this a single bullet point out of this long email I can pretend I read. Well, we all uh, know that kind of phenomenon, and I know it's funny. I asked ChatGPT to explain what this figure was about, and I just uploaded the figure. It extracted the text from the figure, and here's the response it gave. This cartoon is a humorous take on how AI is used in the workplace to manage communication. On the left, an employee is bragging about how AI can expand a single bullet point into a long email so they can pretend they've written themselves. This suggests that the AI is doing the heavy lifting in terms of communication, allowing the person to seem more verbose or engaged than they actually are. On the right, another employee boasts about how AI condenses a long email into a single bullet point, which enables them to pretend they've read and comprehended the entire content. Both panels are satirical comments on how AI can contribute to a lack of genuine communication in the office, with people relying on it to either inflate their own input or reduce their need to engage with others' messages. And I was particularly interested that ChatGPT didn't add some kind of snide comment about, and you stupid humans will don't learn, do you? So more time would allow, to look at more examples, but we can experiment with, relatively newest versions of these systems for free or for very little cost, to experiment with them. And here are some examples of these. One thing I did, like about 6 weeks ago, is I uploaded a picture of the statue of True Grit that's on the UNBC campus. And I asked ChatGPT to construct a picture of a robotic version of True Grit. And, I generated a couple of them, and here's the one I particularly liked. But it can do a lot of things if you experiment with it. Now, there are some concerns, as I mentioned. The generative AI systems can be used to create disinformation and deepfakes. This is in the news a lot right now. The deepfakes might be images, or it could be video showing someone like Donald Trump or Joe Biden saying things that uh, they didn't say, and affecting the video using them to make the mouth seem to be saying aligned with what they're saying. Uh, these things, there are many possible negative impacts on society and climate that people are worried about. Besides disinformation and deepfakes, for example, eliminating jobs and disrupting education, using too much energy to develop and deploy. You look at the amount of energy it's taken to develop these systems; it's huge. And using private data without approval, including copyrighted data. They can also be misused for tasks that should be done by people. For example, for a student using it to help them do a take-home exam, for researchers writing and reviewing papers. So it's not good if you ask the ChatGPT system to write the whole paper for you and don't review what it's generated, or ask it to fulfill your obligation to review a paper for a journal or a conference. So, but the worst concern people have is that we might create an AGI that we could not control, and it might do things that would be bad. What is an AGI? Well, we think of it as a system that can understand and do any intellectual task that a human could do, as opposed to the narrow AI systems that are mostly used today, and including the generative AI systems that can't do everything that a human intellectually can do. So AGIs are expected to have the capacity to learn to do new things, to reason about problem solving, and maybe to be conscious and self-aware. So AGIs are currently theoretical, but AI progress raises hopes and fears about them. The potential benefits are obvious. They could help us solve complex problems. They could automate and optimize tasks for economic growth and better quality of life. They could augment human intelligence and creativity that could open up new possibilities in science, art, and information. And they could revolutionize things like a medical diagnosis, which would be great. But there are risks and fears as well. Maybe they could have harmful consequences that are unintended that we can't predict. They may be difficult or impossible to control, leading to existential risks. Well, they could automate many jobs done by people, which could lead to vast unemployment and social unrest. And the big fear is they might be used to develop autonomous weapon systems, threatening global security and maybe misused. So there's some talk today about AI doomers and AI boomers and P-doom. AI doomers have a very pessimistic view of AI's development and its implication for humanity, where the boomers hold an optimistic view of AI and its potential benefits. And to a large degree, I think this is maybe a personality issue, whether you're prone to be a pessimist or an optimist. I'll admit to being an AI boomer, but the AI doomers do have, points we should consider very carefully. One thing that people talk about lately is P-doom, which is a person's probability estimate that an unchecked AGI could cause an existential catastrophe or even human experience. Elon Musk, for example, has been quoted as saying, oh, he thinks there's a 20% or a 30% probability that this might happen. Jeff Hinton, who was one of the people who invented neural network technology that's being used, is somewhat of an AI, I wouldn't call him doomer, but he's got concerns about how this has worked. He thinks there might be a 10% chance that really bad things could happen with AI. And Jan LeCun, who's a professor at NYU and one of the chief scientists at Facebook, also puts it much lower. He thinks the probability something really bad could happen is much less than 1%. So managing AGIs may be inevitable, but there are ways to manage them. One is by working hard to find ways to align their behavior with human values and goals by adding appropriate guardrails. These open AI systems do have guardrails built in that control what they should and shouldn't do, but it's not a perfect system. People have found ways to overcome some existing guardrails, as you may have seen. And another issue is assuring that the benefits of AGIs are distributed fairly and equitably in our society, and not just used selfishly by some companies or from some certain subset of people. And we definitely do need international collaboration and standards for open dialogue about the potential risks and solutions. And I think that's beginning. So getting back to my initial slide, I don't think we've solved all of AI problems or yet developed an AGI. I don't think AI systems can think like humans do, but we've made good progress in the last few years, and I think more will be made. I think the systems like ChatGPT, and its other similar systems show remarkable and useful capabilities that we all need to understand how to use and to use well in the current environment. Their impact on society were, again, remember Amara's law, that we tend to overestimate the impact it's going to have. But as we look back in 10 years and 20 years, we'll think, oh yeah, they helped a little bit, and it wasn't that big a deal. Just as we look back on the web today, we don't remember, many of us, what the world was like before so much information was available easily on the World Wide Web. Now, again, just yesterday, I put that question, can machines think? Oh, I even misspelled it here into Gemini 1.5 Pro. Gemini didn't understand, understood me to be probably asking, can machines think? And it gave this answer, which is pretty good. But again, it points out that there are shortcomings in the way machines can think right now, and maybe future AI systems will be better at it, and maybe they won't. I tried it on the ChatGPT Model 4 as well, and it kind of gave a similar answer. Oh, yeah, here's the corrected version. I guess I left the bad slide in there where I spelled can right. And I appreciated the fact that Gemini didn't point out my dumb mistake explicitly. And you notice that the answers are a little bit different, and that's something that you have to get used to when you ask the same question several times to these systems. You'll get back slightly different answers because they are probabilistic still. So that's my answer, like ChatGPT and Gemini. I think that machines have gotten much better in the last 3 years, really, at being able to do what we call thinking, and they're increasing still, but they are not AGIs. They can't think at the level that most humans can, but they're very useful systems and they have access to a lot of information. So the degree to which they can think and answer questions from it is very useful. So I thank you for listening to my presentation, and I'll stop sharing my screen and be happy to answer any questions anyone might have.
Thank you so much, Dr. Finin. That was amazing. I maybe speak for everyone else, especially from the library. We appreciate you putting in a slide about citations. You gave PubMed a little shout out. I do see that John has a question. Go ahead and feel free to ask.
Thanks, Tim. It's hard not to imagine a holodeck is next on the horizon with the large language models. But I know there's been a lot of concern with faculty sometimes about how students might abuse AI for representing work that they've not done on their own. I have a different sort of question for you.
Right.
Would it be unethical for a student to use AI to ask it to ask the student questions for an upcoming exam based on the professor's presentations, notes, or handouts?
Oh, that's interesting. I haven't thought about that before, but my first guess is I think that sounds reasonable. You know, a student might ask, you know, an upperclassman the similar thing, and we, you know, wouldn't thought that was sort of cheating. One problem is that there is a lot of, I tended to put a lot of information about my old exams online, and I, well, okay, I'd have to think about this, but I think it sounds reasonable. It doesn't sound too bad to me. I'd be happy to hear comments of, you know, how to modify this though. There've been, oh, go ahead.
John, this is Mona, and Tim, you also. I have used ChatGPT for one of my courses, and I just did it out of fun. Um, I teach introductory Java programming, so whatever content I had covered, I had asked ChatGPT to create some study guide or questions for students who use for their midterm.
Oh,
Um, so, but I had to go back, and some of the answers were not 100% correct, or there could be multiple choices which could be correct. But just for sake of seeing what I get, I did use that, to create a study guide for my students.
yeah, yeah. Well, I think if a student asks an upperclassman for, you know, how to answer a certain question, they'd often get answers that were a little bit wrong too. So, you know, it's too high a bar to say that chat GPT's like systems have to be right 100% of the time. But you know, that is a problem. I do worry about what we do learn if we struggle to learn on our own. do we learn better? But the time will tell, I think, how that works.
Thanks, Tim.
There have been a couple of recent papers that maybe if others have seen, that were quite surprising. People have studied, for example, of the reviews that people have given for conference and journal papers, and developed systems to detect when the reviews are likely written by a system like ChatGPT. And that was pretty shocking how common that was. And the same thing has been done for papers that have been published. And maybe most of them were published on archive, but some of them, I think, in real journals and conferences, where you could find telltale phrases that the chat systems stick in their text. And it's obvious that somebody had the chat system generate a paragraph for them, and they just cut and pasted it without editing it very carefully. So these kind of things are shocking, and they weren't students. I think they were probably, well, they might have been like PhD students, but I think many of them in both cases were, working professionals and maybe professors. But that's human nature, I think. Not everybody is doing what they should be doing all the time.
We do have a question in the chat. Maria asks, what do you think about using ChatGPT as a draft and then editing it
As a what? Oh,
as a draft?
well, I've got mixed feelings. I will admit, I think it's good for us to write things on our own, but I will admit to occasionally when I'm kind of stuck on how to say something, I'll put something into a chat system and see what it says and think about it. A lot of the time, I don't like what it says. Often the responses tend to be a little too general, and the style of writing is a little stilted, I think. So um, I guess if I had to give an answer, I'd say, well, I occasionally have to do something like that. I occasionally do something like that, but then I usually use that as an inspiration and maybe use a few sentences, but largely rewrite it on my own.
Any other questions? We've got about 2 minutes left. Oh, Herbie has a question. What about instructors who use it for grading? I've read that students in classes with such instructors have erroneously been accused of cheating.
I well, there are systems that can help detect when some text has been generated by a ChatGPT system, and if an instructor has said in the class, you're not allowed to use these systems to answer the questions, that would be uh, reasonable for instructor if the instructor is confident that something was generated automatically, maybe to mark it as wrong, but they should be willing to talk to the student. However, that's still a sort of a difficult point. I think having in-person exams now is more important than it used to be, as opposed to take-home exams, because that's an environment where you can find out what a person has learned without being able to rely on the internet and chat-like systems to answer certain questions. I think it's a little risky to have ChatGPT just say, "Oh, this is written by a chat system," or "This wasn't." So we have to be careful as instructors to flag somebody as having cheated without very clear evidence, I think.
I think Roberto had his hand raised.
Yeah.
Did Roberto leave? Yeah, go ahead, Roberto.
Oh, hi. Fantastic talk, Tim, as always. I wanted to hear your thoughts about confidentiality, right? Like now, let's look at the example of the university. Someone was mentioning, what if students were to put the material out there to get some questionnaires, right? But that material has been generated from, someone has generated that material, right? For example, us as the faculty, and not everybody puts their material online. But now a student is putting the material out there, and OpenAI can potentially, I don't know, write a book on the topic that you're teaching, right? So how do you feel about this confidentiality issue? Do you think that we should have limits on, it's difficult to enforce, but on what people should put or not put into those systems?
Yeah, it's a good question. I think as a collectively we haven't worked through all the details of this, but that is a problem. You might put something online and you might explicitly say, you know, how it can and can't be used, but the ChatGPT systems might just scoop it up anyway. And that seems wrong. On the other hand, you know, I've put a lot of my educational material online, and I just assume that students will use it any way they want. And I always kept some of the exam questions not online, just to sort of give me a little more room to use them with students not having seen them and the correct answers. I don't know, difficult problem. And I think that's going to be hard for us to work through.
Thanks.
Okay, we are a minute past 1. Thank you all for attending today's session. We will be sending out the recording after it is processed. I'm going to go ahead and stop recording.